My name is John Day here, and I'm the technical marketing engineer here for the Contiv product. And I guess first, before I go off on my statement here in slides, I just wanted to kind of give you another example of what we had on using the VLAN kind of mode for companies that already have a data center where they've got this environment. And the case story would be where you have a customer that they're deploying VMs, and let's just say in a static sense, they're deploying web servers for their static content and they're getting ready. They know that when Black Friday comes up, that because they're monitoring with App Dynamics or whatever, that it takes them XYZ much longer time to be able to spool up these static web servers, using VMs, which are these whole static VMs. So they've already got their load balance and everything set to scale for when they have to, execute and run more VMs. But the developers are finding, it's much quicker and easier for me to set these things up in a Docker container. So using this VLAN kind of mode, that you could switch over, you could replace out those those VMs that you deploy that take minutes to seconds in a kind of a deployment, that you'd have that kind of environment. So where you go from that point. The other standpoint, I don't know if Meenakshi really mentioned it too, is because we're not going through the main interface and we're not using the full IP stack, that we have our own OVS switch and the flow tables in that environment, that we're just tagging packets. We don't have to do any compute for any of the VXLAN, overlay, overhead, or anything else that goes with it. So there are some other advantages that do come with it as far as the raw speed, because now with the VNICs and everything that come like in a UCS environment, you can tap these containers straight onto a 10 gig, 40 gig, virtual pipe that comes with it.
Yeah, and I think my questions around it, and this is traditional. I haven't updated myself on container networking in some months, but the complexity or the challenge was in the overhead needing to spin up and down containers and all of the services that we've traditionally, TCAM tables, ARP, all of that stuff that needs to happen, and then IP address management and registering service discovery and everything that needs to take place to do that rapidly up and down. That complexity is sounds like it's moved into the orchestration piece of it versus trying to handle that with traditional tooling.
Correct. I mean, like an example, you could set a range for our group that we're going to run for web servers. Hey, anything that's going to be from .100 to .200, these could all be web servers. Mm-hmm. They might not be online, but you just tell the F5 or whatever, hey, you monitor these, and if any of these ports are up and you can get port 80, it's a load balanceable item. So you can have those go up and down all day long. Again, this is the high-level architecture of what we're talking about here for the Contiv networking plugin model. And so, again, where we have is a CNI and CNN plugin model that obviously works for both the Kubernetes orchestration engine and the Docker orchestration engine as well, for Docker Swarm. And not only is it Docker Swarm, but it's the Docker Swarm V2 plugin. We're one of the few people that is Docker certified for the V2 plugin to be able to provide this swarm mode that we've got set up that runs in Docker Enterprise, UCP, and everything else that comes with it. And in the same breath, also have it run in a Kubernetes and OpenShift. And so we have it really comprised of a simple item where there's a manager that's put in place here, what we call a Contiv master. And then on all of the nodes that we're running this environment on is going to be the net plugin environment. And between this, we have our own containerized applications where we have all the user space bits that we need for the OVS that we're going to control on that host. And then we maintain our state using an etcd, key value store environment. That's where everything is published, and that's where those values are set up. So commands are sent via, command line that really gets interpreted to an API command. We also have a web proxy API that comes with it, or you can send the command lines, directly yourself to the netmaster. The netmaster is going to go ahead and it's going to set that policy up, and it's going to then push the policies out that it needs to all the hosts to say, okay, here's the new rules, here's the new flows that you're going to implement for your OVS switch for your environment, whether it be VXLAN or if it's going to be doing VXLAN or VLAN encapsulation. Any current questions on this? Right? So, real quick to talk about, we have the group-based policy framework in our container isolation. And what's nice about this is, again, regardless of whether or not we're going to be using a VLAN or a VXLAN environment, the policy information gets to stay the same in our group-based policy. So now, in these environments that we do set up, or like in a brownfield environment, whatnot, you can go ahead and now set up that within the network that you create for this environment to run in, you can now have container security to ensure that the web group for the web containers can only talk to the app containers on specific ports, and that the app group can always talk to the DB group and never allow the web group to talk to the DB group. So if there ever was a vulnerability that was in your web data, in your web container for some reason, that even if they did get in for somehow, that they could never get to the database directly, that they'd still have to go through, they could only ever access and talk to the app container in that environment, but it would still be in the same network.
What if they compromise the app container then?
I'm sorry?
So I'm looking at what you have here. It looks like three-tier web, app, and DB.
Sure.
So you're saying app can only talk to DB, but web can't talk to DB.
Correct.
So you said if the web gets compromised, they can't go to the database directly, but if the app gets compromised, then they can.
Well, okay, so yes, I'd have to compromise 2 containers to get to the database.
No, they just have to compromise one, the app group.
Right, well, in this case, it would be that everything goes through the web container itself to then communicate to the app itself.
What through? What do you
mean?
Like you're going to expose the web group on the internet and then put the app behind a firewall, or?
Well, no, it would be a pass-through or whatever from the app, from the web group to the application itself exactly.
Okay, so it's not TCP routing as such.
Again, it would depend on how you're going to continue, how you're going to build the application in its own accord.
So you're saying there's no risk that someone could get to that app group?
No, I'm not saying that. Whoa. I'm not signing any kind of document on that one. No, but all I'm trying to point out is that when you go ahead and you create a container, that this container has policies to only talk to another container, despite it being on the same network, despite it being there and have other, that no, you can only talk from one container to this container on the load policy.
Micro-segmentation.
Correct, very good. The micro-segmentation.
It's definitely important to have that.
So, all right, so here we go. So what I'm going to do here is I'm going to visually display here, this is an animated slide on what I'm going to show you in the demo that's going to come after this here. So we've got a computer out on the, on our VLAN 219 network, and we've got 4 hosts that are set up in our Docker Enterprise environment. And we're going to go and show you, I'm going to go and show you the steps that are issued in command to create the Docker network environment that we've got here, and show the packet flows that I'm going to demonstrate in the demonstration here. That was a bit redundant. So in our environment, and again, this is all pretty much going over our VLAN bridge environment, kind of tying in with what we're doing here with our CVD. So we're going to issue our network group create command, and then with that, we create our network, and then we're going to create these network groups that we've been talking about, the web app and the DB group. Again, they're all associated with that subnet of 29.21.0.24, which is in itself a VLAN environment that's sitting into a data center environment. We spool this up. The Open vSwitch is attached to that second interface. So in this environment, there's 2 interfaces. There's the control interface that we talk to everything over ETH0, and then there's going to be the data plane interface that we're going to use for all of our containers. That's attached over on that bridge in itself. So once we've gone and we've created from our Contiv standpoint, in Docker, in the Docker environment, we have to now go and make a relationship here, where even though we have our groups that we've got an assignment, in Docker we need to create those as Docker networks. So with that and the V2 plugin that we've got set up, we're going to go ahead and we're going to do our Docker network create, and we're going to reference our Contiv plugin, and we're going to reference the group names that we had that were set up in the tags for web, app, and DB. And we also have our own IPAM driver that does the IP assignments when you spool up these containers into their environment. So once we go ahead and we do that, we now create this web, app, and DB groups that can now be referenced in Docker when you go ahead and run. So now we're going to have those containers that are going to be able to run. What it thinks is as a network is really a group in the entire network that we've got set up. So we're going to have, and so in this case, we're going to run Docker services, and again, we're referencing our production AWeb, product AWeb, DB, and app, groups right there. And so we're going to start these up. And so we're going to see here with our replicas, we're going to run 2 web servers, and we're going to make sure that we apply our container policies. And because we've also done the port forwarding, that there's a Docker ingress overlay that's going to happen too here. And because it's still a full V2 compliant environment, we have the ability where everything that you did with Docker and its overlay environments for doing its routing mesh environment is going to be implemented and will be able to work as well as the backend environment that we provide for our data plane. And then subsequently, we also run our app and DB that are going to be in their own groups that are on their own machines or wherever they are. So with this environment, so we're going to show, just the standard Docker routing mesh environment that comes up with it. So regardless of what port that we spend it on, when we come out from a computer, it's going to go through the routing environment. It's going to go through the ingress overlay, through the IPVS, and it's going to load balance between the two web servers that you see. And it's going to be the same regardless of which host that you pick. This is standard Docker, ingress overlay. So again, everything that worked with Docker and its native modes still works in our whole, in our environments for Contiv. And I'll show the fourth one. All right. So now we were talking, because we are VLAN connected and these containers actually have endpoints that are on the network, we can actually still go from the same host and we can now directly route to those containers that were generated on their environments. And notice we don't have to go through port 80, 8080 that we had, because the web service does run on port 80. We can access these containers directly on port 80 as they are. So there you go. The packets go through the router, through that VLAN mode, through the OVS switch, and then we're done. Well, so again, going back to our policy, our group policy methods, that if we do have a policy that does allow it from our web to app group, that you would be able to go, and again, it does everything over the VLAN method, where it's going to go from that web 1 to the app 1 container, and then same lies with the app 1 container to the database container.
What's the performance difference between this and something like an SDN, like what Nuage are doing, or maybe Weave works?
It's a good question. I haven't done any performance testing on my own, of course, on that between the groups yet.
What about just general pros and cons over a pure SDN where it's all driver based? Because I can see these pictures that you have there. Are they Cisco specific hardware?
No. This doesn't really matter what kind of hardware this is.
This is an SDN completely. There's no hardware.
Yeah, well, you don't need
Involved in the.
Correct. There's no Cisco hardware. There's no configuration. Obviously, the VLAN has to be set up by the the network team, and that environment has to be connected to that interface port.
Yeah, so it's just that we are the CNI plugin, so we get the state change events, and every time the application or the containers migrate, we are able to apply the policies at the right place.
Okay, cool. Thanks.
All right, and then finally, obviously, is our outbound connection. Again, because it's an endpoint that exists on the network, it's going to route through the router just like any other virtual machine or bare metal environment. And again, like I said, or you had asked earlier, this is agnostic completely. This could be on any kind of networking hardware itself. It's just your standard VLAN environment. Doesn't matter if it's bare metal, virtual machines, whatnot in that environment, as long as you can have packets go through there, because it's going to tag packets out to that network, and then it's up to the network to route those packets to and fro. Okay, so with that, I'm going to go ahead and I'm going to switch over to the demo. So here we are, same thing. We have an environment, 4 nodes in a Docker Enterprise 1706 environment. We have it, we have our UCP cluster that's set up here. So this is really just showing where we're at here, that we're going to be using VLAN ranges. In this case, 2921 through 2929. We're using our bridge mode. That we're going to do ARP proxying, which I guess is another item that we can do to, when you do get to a lot of containers, that you can mitigate that by doing proxy ARP rather than having to do proxy flood. Again, this is just everything that we saw in the slides, where we're going through here and we're creating this network, and that we're going to say anything that's going to be tagged out, it's going to be tagged out on that packet 2921 for the VLAN environment. And then we've gone here into this environment where we've now created our endpoint groups that we've associated to that network, product A. And so we've created our app and DB web. And then we've also gone in addition and created our web to DB policy and our app to DB policy. You guys have any questions, just tell me, I can pause it. So this is just our first issuing of commands for our netcuddle commands. Netcuddle is our command interpreter that we send to the netmaster that sends all these policies through. Where we're going to say, we're going to deny all, but we are going to allow port 666. that comes from the app group, and that's going to be attached to the, as we showed with the endpoint group, it was attached to the database group. And then the same thing goes with the web group. This container all runs, they all have a port listed on 666, but it's really indifferent. It's just a light app to be able to show all this. So again, now we're at our point where we're creating our Docker network associations. We're taking that web app and DB endpoint groups, and we're creating those as network and Docker. And then we can go ahead and we actually start these services up now. We're going to start a replication for our web services, our app, and our DB service as well. So they're going to run and spool up. And we're going to go ahead and get some of these IP addresses out of them here. And as you can see, we've got the IP addresses for our app and our DB and our web group. And because that web group, we started out with that -P, because that service mesh, there's two IP addresses here. There's the 10.255.0.7, which is the ingress overlay for the routing mesh environment. And then everything else that you see is the 2921, like 0304, 6, and 8, which are the actual endpoint addresses for these containers that are on that VLAN network itself. So if we go ahead and we look at it, we can see these containers exist. So as a side here, we'll go ahead and we'll do a routing mesh test. We'll go ahead and we'll, like I did in the video, in the animated slide, we're going to go ahead and we're going to ping, and we're going to see that the IPVS on all those components, regardless of which host I hit, 203, 204, 205, 206, it's going to load balance between those containers using the Docker side of that environment. And then again, from this container, from this endpoint out here, we can also use our direct connection where we can go ahead and test out for the .3 and the .4 that actually exist, and they're going to return their own individual IP addresses in that case. So you can get to the containers from the front end service, the service route, or you can get to it directly as a container seen as an endpoint. So right now, we're just really running through the policies to show that we can connect from web to the app container. And I do port 666 and 667 to show that, there is no 667 to show that it's not working. There's nothing there. And that you can't get from web to DB in this environment. So this is where these policies are applied.
Is all the lag something you've introduced so you can talk it through, or is it normally this slow?
I'm sorry?
Is it normally this slow to set up, or is it sleeps that you've put in?
No, yeah, there's 14-second sleeps in all these.
Okay, right.
Yeah, if I ran through, if we could run through this, there's. So yeah, I've sped this up. I've slowed it down so I can pause to talk about it. Yeah, no, yeah. That wait prompt. I'll show you the function just to show you if you don't believe me. So yeah, it's not that it's that slow. I just have to give it time so I can talk about it, because when I make the videos, I give myself more time than I cut out the shorter instance for the.
This is just coming from the kernel, so it's pretty quick.
Correct. Anyway, so again, talking that we can go from the app to the database container. So again, this is really just showing that you can't go from your web to the database, because that policy doesn't allow. There is not a policy allow.
Can you explain what you're doing there?
Yes, I can. So I'm just running a Docker exec, but I want to make sure that I go into the app1 container. And so for me to do that, I'm running just a service to find out what is the UID or whatever for that app1 container that's currently running. And then with that, I just run a netcat to the database IP that I collected from up top to scan those ports.
Just out of interest, does that work only if you're on the host that's got that container on it? Because that's what I thought with exec on Swarm.
Does it?
When you exec into a container that's created by Swarm, you normally have to be on the machine that it's on.
No, I don't. Okay, so again, there's more to my script than you're seeing here. So I have, when I've set up on my entire environment, I've downloaded the UCP credentials. So when I source that, when I go through there and I write that command, then that gives me the ability to like Docker PS, and I can see all the containers that are running. So when I run this, I actually run that Docker exec.
On every node?
Yeah, I can. So I can be on, so right now I'm on like the 203 node, and this container could be running on 204, 205, 206.
Can you do that with CE? Can you do that with Docker CE?
Docker CE, yeah, I don't see why you couldn't.
Figure out what node it's on, literally log on with SSH, hope you've got the right one, and then do your exec. But the syntax here, app.1. I want to try this out later.
Okay. Well, I'll do you one better. I'll even send you the script that runs all this stuff as well. All right. So anyway, so again, this is just showing the whole app to the database container that this part is working.
If you've got a mix of syntaxes here from the various things, so I'm looking at this as a networking noob, a Docker noob. I don't know anything about it, honestly. So is this a mix of Contiv and Docker that's in your script here, CLI command?
Correct. Well, yeah. So anything that's a netcuddle is the Contiv section. Anything that starts with Docker is the Docker command section of it. Okay. So it can be sectioned out. And I don't have a video for this yet for Docker. We're waiting until we get everything finished with the CVD. But I also have a full GUI video, like for a Kubernetes example. I have a full VXLAN where we use our GUI and then the Kubernetes, what's it called, the console, or the GUI console that it has, to show the separation, how that's set up. So we can do all that stuff too.
I do like a GUI.
Right. So there is the GUI, and it's coming there. But again, so going back here, here's our outbound ping. So here's us logging into a container, and then I'm just doing a trace route to another subnet itself, and it's showing you, hey, it's routing out there and getting to that other subnet. So those containers, like I said, they can get to anything as long as the router will allow it, or firewalls or anything else that comes with it. And I already showed you up in the top here how you're able to actually get to those containers from the outbound as well. So there's the ingress, egress, and everything over that VLAN environment. So yeah, that's why I wanted to show the animated slide first, to show what's going to happen before I just go into the straight CLI environment.
Yeah, makes sense.
So after this, there's a cleanup of the environment, and that would clean it up. This is where I'm just tearing down all the services, taking away all the networks, and then taking away all the policies that come with it, take us back to state 0, so I could run the test again. Questions?
So what hardware requirements do you have? Does this work with other gear as well? Or does it require, what Cisco gear does it require?
No, so we are an open source. So Contiv really is an open source product in this case. So if you want to do BGP on another network instance, you can do that. If you want to do it on VLAN or mixed array, you can do all that stuff. Mm-hmm. Yeah, again, once we get to the point on our OVS switch and we say, hey, in this case, especially in this case, or actually it doesn't really matter, a VLAN tag's a VLAN tag. It's a standard. We're not doing Cisco VLAN tags or anything like that. So there's nothing, that's appended or funny to it.
The ulterior motive is, of course, like to drive the ACI adoption, I think.
Well, yeah, I'm not going to deny that fact. I mean, yes, there is an ACI feature that comes with that, with a fabric kind of environment. But again, Contiv in itself, because of the open source, it is also making it so that you can run it in the cloud and in your data center environments for your hybrid environments. Mm-hmm. And what's nice about this is that it gives you, it's the same kind of look and feel. The policy model that you write to run in the cloud is the same as the policy model that you could run in the data center. Mm-hmm. So, and again, going back to the Docker Kubernetes thing, if you wanted to switch one between the other, in this current mode of the group-based policy model, it all stays the same, even without the sound effect of me whistling too. So.
And we have customers who buy Contiv without ACI.
Correct. Yeah.
Many of our customers are like that because they are not tied to ACI.
Correct. It works for both environments.
Is it by Contiv?
So yeah, it's 100% open source. Mm-hmm. We do have a support and subscription model. Mm-hmm. There are a lot of customers who just download and don't use support and subscription, and some who are deploying in production do. So.
Mm-hmm. Okay.
Correct. So if you were going to ask me a question, well, how many people are using Contiv? I can't actually tell you. The only way I could tell you is if we were contacted directly, and that would be it.
Support-wise.
Support-wise or support otherwise, or if they wanted to buy support. But other than that, we can't. There is no true depth because it's an open source thing. I don't get to see how many downloads that occur.